Hey, what's happening, guys? Look, it's another oscilloscope. Oh my. I now have as many oscilloscopes as I do multimeters. I swear it's not an addiction. It's a collection. Anyway, this is the Owon XDS3064E. It is 4-channel, 60 or 100 megahertz. I bought the 60 megahertz version. I'm sure there's a way to make it 100 megahertz. Wink, wink. 1 giga sample per second. Let's see. It has an 8-inch, 800 by 600 TFT touchscreen display. AC-DC coupling up to 200 volts. The time base is down to 2 nanoseconds per division, and the memory is 40 megabits per channel. That is really nice. The vertical is 12-bit. Analog digital converter sensitivity is 1 millivolt per division to 10 volts per division, with a displacement of 2 nanoseconds per division to 1,000 seconds per division. Trigger on channel 1, 2, and external. It has cursor measurement of delta V and delta T. Auto measurements, has 100 of them. It also has bus decoding for I2C, SPI, RS-232, UART, and CAN. All standard and included. That's pretty nice. This lists for about $3.99 on Amazon. I put it in my Amazon store because even though I'm going to knock this in a couple places, it is a really nice scope, and it's a nice step-up scope from, say, a 2-channel Handtech or a 2-channel Siglin. I like it. It's got some issues, but all scopes do in this price range. I mean, if you want perfection, then go buy yourself a Roden Schwartz or a high-end Tektronix. But for the home guy, you know, this is pretty sweet. Let's start off about... Well, that didn't make any sense. Let's start off talking about the probes. And you get 4 probes with it, of course, and they're your standard lower-end multimeter probes. Just what you'd expect. These are 60 megahertz probes. They are 10-to-1 attenuation switchable. You're going to want to use them on times 10. Dave Jones has a wonderful video about why. I'm not going to go into it, so search Dave Jones on probe attenuation, EEV blog probe attenuation, if you want to understand why. It's just too much for me to go into an oscilloscope review. So you get 2 identical packs of probes. And you see our input capacitance, 14.5 to 17.5 picofarads. And here you have the system bandwidth. At 1x, you're only getting 6 megahertz bandwidth. At 10x, you get the full 60 megahertz bandwidth. Decent enough probes, everything's good. Okay, here's where Owon, I don't know if they've cheaped out or if they've overlooked it or what. If you look at the scope, you see our colors are yellow, blue, orange, and green. What you get with the probe are yellow, red, green, and pink. There's no blue, there's no orange. Come on, guys. What's up with that? You can do better. Get the right color rings in there. Now, you also get, if I can get it to open, with my giant fingers, which everybody just loves to make fun of on YouTube. Read the description. Have a medical condition called congestive heart failure. That's why my hands are swollen. You ought to see my feet. Some days I can't even get shoes on. Anyway, these little springy things, what you can do with them, take this off, take that off. This goes on here. It goes all the way back. I'm not going to put it on. And then you can probe your circuit with this being your ground lead. If you're dealing with anything in the megahertz range, which is basically the RF range, yes, I know RF goes lower, but let's just consider megahertz range, the RF range. This 6-inch wire here basically becomes an antenna, and you don't want that. So that allows you to eliminate that. Then you also have these little caps that go over your probe tips to keep you from shorting things out. That's all nice. They really screwed up on the colors. Now, let me see the size on this thing. Had it in here somewhere. 340 millimeters by 177 millimeters by 90 millimeters. It is, it's pretty thin. If we take a look at the back, you see we have our power, we have an external ground. You can get a VGA with this. I did not get the VGA option. It has a LAN port. It has a USB port. Over here we have a trigger out, also a pass-fail. So that's pretty nice, and it is quite light. Now, in order to save space, we don't have vertical controls for individual channels. You have to select them with the buttons. I mean, it's not great, it's not terrible. It simply is what it is. Of course, it has your little square wave generator for probe compensation, as you can see here. And we can just turn off those channels. Move these guys over. And this is full bandwidth, so you're seeing a little bit of noise there. The position buttons are, of course, clickable, which is what you want. I'll turn off our channel 2 there. Now, again, I said this is a touchscreen oscilloscope, and that works out very nicely. It also has a multi-touch so that we can pinch and zoom. How about that? That's pretty nice. Now, if we want to bring up our channel menu, we hit the button and the channel menu comes up here, and you see we have coupling, DC, AC, and ground, inverted on, off. Our probe, which is set to 10, we can set it down as low as 0.001 and as high as 10,000, which works really nice. We can also tell it if we're measuring voltage or current. Then we have our bandwidth limiting here, full bandwidth, and we can switch it to 20 megahertz. Yeah, 20 megahertz limiting on the band. Also come down here and touch our home menu, and you can see all of our different buttons here that match our functions up here. So we can go into our acquire mode, sample, peak detect, and average, which is nice. There's 4 averages, and we can take those averages. There's 128 down to 4. That works out really nice. We can also do our record length here from 10K up to 40 megs. And then we have our interpolation of sine X on X, or simply X. Leave it on sine X on X. You don't need to mess with that. We have our utility menu here, where we can have our function configure, display, adjust, pass fail, output, LAN set, update. So you see we come in here and hit our display button. Then we have our backlight at 100%. What type of graticule we want. This is a battery operated scope. I don't have a battery in there right now. We can save our waveform. What do we want to save? Do we want to save a wave, figure, image, record? We can clone. A lot of nice stuff there. What source are we coming from? All of our channels. Object and show. We can show our saved waveforms. All very nice stuff there. Display, we have our trigger menu. And there's a lot of stuff in here. We're getting into that further. We can trigger on edge, video, pulse, slope, run, windows, timeout, and whoop, hey, get back there. This one, I have to do this, nth edge. Okay, so those are our single triggers. We also have logic triggers, which we can type. Our type is logic. What logic mode are we looking for? We can do AND or XOR, XNOR. Let's go back here, logic. Then we have our bus triggers, RS-232, I2C, SPI, and CAN bus. So that stuff is all very nice there. Then we have our measurements. We can add our different measurements in. Period, frequency, mean, peak to peak, RMS, max, min, top, base, amplitude, overshoot, pre-shoot, rise time, fall time, plus pulse width, negative pulse width, plus duty cycle, negative duty cycle. Delay between A and B. What's that? With a rising edge, delay A to B, falling edge, cycle RMS, screen duty cycle, phase A, B rising, phase A to B falling. Plus pulse count, negative pulse count, rising edge count, falling edge count, area, and cycle area. That's a lot of stuff. And, get that out of there. If you just come over here and hit the snapshot button, it simply brings all those up and shows you at once if you just want to grab a quick measurement. So that is all really sweet. We have our cursors. We can do voltage, time and voltage, or an auto cursor. I mean, it works great. And turn that off. Boom. Yeah. Okay. We have our help menu, which is quite extensive. Hello, help menu. There we go. I mean, you can roll through here and just read all this stuff, including how to connect this thing to the Owon Wi-Fi software. Yes, it has Wi-Fi. You can output this to your phone. Really, really cool stuff here. Now, it has an option for a built-in function generator and multimeter. I didn't get either one of those, so if you press the data acquisition, nothing happens. We also have a waveform button over here for recording our waveforms. All very simple. Here's our trigger menu over here. We have our trigger menu buttons there, force trigger. And if you press this, you get a 50% trigger, which is excellent. Every scope should have that. Somebody's been playing with your scope, or you have a bunch of things, you can always just hit default twice, and it goes back to its standard settings from when it was factory fresh. I think it's really featured. Let's take a look at some other waveforms. Okay, I've got the Jungtech JDS2800 DDS signal generator running here, and we're giving it a 10 kilohertz sine wave. So if I hit display, counter, there we go. So now we have our counter on, and you can see it's got a really nice display. We can also go in here and turn on persistence or color. Can't have them both. Now what color shows you is the intensity of the waveform. So it kind of acts like a thermal imaging camera, where the red is the most intense and the blue is the least intense. I'll show you more of that later on. Let's turn on some persistence here. We'll go with 2 seconds, which is a little long, but it'll allow you to get the idea. And what I'm going to do here is I'm going to modulate this waveform. This is going to be a 2-second logarithmic sweep. Ready? There we go. Now let's go back into our persistence, change that to 1 second. And you can see how that looks. Then we'll go back in here and we'll turn our persistence off. But let's turn the color on. And you can see how those colors, you get a little bit of that blue and yellow on the outskirts, showing you sample points that aren't being used as often. So that works really nice. We can take a look at some different waves. There, yeah, okay, there's our 10 kilo. Oh no, what are we at here? Let me whoops. Let me adjust our frequency here. 1 second. Okay, so there is a 100 megahertz 5 volt peak to peak wave. And then if we bring up all our measurements here, you can see there's our period, our mean, RMS, our overshoot, rise time. I mean, man, it's just all kinds of. Take it up, there's 200 megahertz, 300 megahertz, 400 megahertz, 500 megahertz. And let's change our acquisition mode here. We'll go with an average. And see how nice that smooths that out? So there's 900 megahertz. I'm sorry, that was 900 kilohertz. 900,000 kilohertz. Now we're at 1 megahertz. There's 200. I'm sorry, there's 3 megahertz, 4, 5, 6, 7, 8. You get the idea. We're still getting that nice smooth wave because we're using the average mode, and we can change our averages here. We can go up to 128 averages. See how slow it is? It's averaging out all of those waveforms. Now, if we come in here and say display, persistence, and color, we'll turn color on. Oh, it's disabled, sorry. But we can turn persistence on. Let's go up to 10 megahertz. Let's go up to 20. Isn't that cool? Of course, like I have said in the past, you're generally better off to keep your acquisition mode into a straight sampling mode or a peak detect mode. One of the two. Averaging is good, but you're not really seeing the true waveform. So if you have any minor blips or spikes, you're going to miss them. So there's a square wave at 20 megahertz. Now that's the generator doing that, not the oscilloscope. So if I turn the frequency down here, there's a kilohertz, there's 1K. And you can see we get a much better looking wave. Again, that's just a function of a cheap arbitrary waveform generator. The scope has no problem at all showing these waves. So yeah, this is turning out to be a nice oscilloscope for the price. Like I said, it's a really good step up. Who? Really? Okay. Somebody out there said, why don't you tear it apart? Well, I don't know. Why don't I? Let's do it. I've got a screwdriver right here. For all the noise, guys, I got the air conditioning on. It's about 88 degrees in here, and the train is coming by. God, I hate these trains. Anyway, I plan to do the teardown on Saturday. Yeah, so I'd have everything done and uploaded for Monday. But at midnight Friday night, my aunt called me to tell me that her husband had died unexpectedly. He was 63 years old. So needless to say, the weekend has been a flurry of activity, and I haven't had time to do the teardown. It will be in the next video, so I'm just going to end this video here. Okay, we'll check out the bus decoding. In this case, we'll do a little SPI. This is just a Nokia 5110 display. And all I've got to do, I know you can't really tell there, is counting millis. So, let me grab my probes. We will do, well, first of all, we'll hook up the ground. We'll set up the clock on channel 1. And the data, which is the MOSI on here, on channel 2. Let's go take a look at the decode function. Okay, we've got everything set up here. And there it goes, program's running, and we get a little bit of decode going on there. I don't know why it's not decoding every time, but it's probably me and something I did and not the scope. We can also take a look in here at the table. And then once it decodes again, we should get a little pop-up there. There we go, telling us our time and the data that was shown. So that works out pretty nice. I'm going to reset it here, and we'll start from the beginning. And we should get another little blip of data here. There we go.